So what if a is not 1? Let's do one like that. We've got 4x squared plus 24x minus 11 equals 0. So we've got an a of 4. I'm going to go through first, and I'm going to divide everything by 4. So I want to keep a nice clean copy of this one. I didn't do that on the last ones, but we didn't really mess with the original. But now, since we're going to be dividing, I'm going to rewrite it so I can see the step, because things get a little messier this time. So I'm going to go through and divide by 4, divide by 4, divide by 4. So I've got x squared plus 6x minus 11/4. And with that, I'm going to move my c, because the whole point of completing the square is to get a new c. So it might be bothering some of you that have the old c has a fraction. That's one of the reasons I wouldn't usually do this when I have a coefficient other than 1. I suppose there are times, but you know, if I'm sitting down to do something, I only pick completing the square when certain parameters are met. So I'm going to do b over 2 squared, 3 squared, which is 9. So I'm going to add 9 to both sides. And this side, factors quick and easy. This side, I'm going to do a little work off to the side to get it to where we can get one number. So I'm going to have to turn 9 into fourths. Right? 9 over 1 times 4 over 4 to convert it into fourths. So it's going to be 36/4. So I'm going to do a little intermediate step here. We have 11/4 plus 36/4. So we have 47/4 here. Does that make sense? Had to get common denominators in order to add that 9 to that improper fraction there. So we've got it all fourths. There's no reason to make it a decimal or to make it a mixed number here, because the next thing I'm going to do, I'm going to take, I don't want that green, I'm going to take the square root of both sides, and I'm going to have plus or minus, and I'm going to go ahead and split that into 2. Now, the example I've given you is not even that bad. It's not even as bad as it could be, because I have a perfect square on the bottom. If I didn't have a perfect square on the bottom, I would have to go through those steps in order to get the square root out of the denominator. But in this case, I had a perfect square in the denominator. I took the square root. I no longer had a square root in the denominator. I'm going to subtract 3. So the answer to this one is x equals -3 plus or minus square root of 47/2. There you go. So that's why, again, you can do them when you have a coefficient that's not 1, but you're going to end up with fractions. So unless you're a real fan of fractions, if nobody's making you do it, I wouldn't do it. I would try 1 or 2 and then know that there's usually a better way. Let's do one that's got another one that I would not do. So again, I'm kind of showing you these. Hey, why would you not do these? Well, I would not do these because why? What's going to happen on this one? Well, on this one, I'm going to move my C. Try to see if you can think of, or if you want to try to do it on your own first, I always encourage that. But what's going to happen here? When is this going to become not so pretty? So far, so good. It's just an a of 1. What could go wrong? What could make this hard? B over 2 squared. Oh, that's why. We're going to have fractions again. 25/4, and that's how we're going to leave it. So on this one, we have our new c is going to be a fraction. 52, no, not 52, 20, 25 over 4. So, yep, we have fractions. So, when I go to factor this, now remember, where did we get that thing that we stick in here? Remember, we always take it, the thing we end up squaring. So you can see this time it's just going to be, a fraction. Okay, all right, so far so good. I'm going to do the work off to the side here to get the 8 into fourths. I just happen to have an 8 again. No, it was a 9 last time. So 8 over 1 times 4 over 4 gives me 32 fourths. So I've got 32 fourths plus 25 fourths. I've got 57 fourths. Okay, we're ready to take the square root of both sides. Got x plus 5 halves equals plus or minus square root of 57. And since you've seen me do it once, I'll just say, oh look, it's over 2. And that's pretty common for it to end up over 2. And what's nice here, I'm going to have minus 5 halves, minus 5 halves. And so there's a couple different ways you could write this. You could write it negative 5 halves plus or minus square root of 57 over 2. Or you could also write it as, right, this is not like an or, like these are two different answers. This is the same answer written two different ways. X equals negative 5 plus or minus square root of 57. They have the same denominator, so we could write it like that, right? So again, another reason why some of these problems I wouldn't do. What made this one end up with fractions? I'm going to let you tell me. What if I just try to do this with all the letters? Somebody must have tried this before. I have to get rid of C. No, wait, before I get rid of C, we said if we have a coefficient that's not 1, we have to divide through by that first. So let's keep our nice clean copy. And we've got ax squared plus bx, looks like an and sign, plus bx plus c equals 0. I have to get rid of that coefficient of a. And this one's going to be a little uglier than my last example like this, because this time my b term is not divisible by a. So I've got x squared plus b over ax, and I'm going to move my c to the other side. I'm going to trust that you believe that I'll end up with negative c over a over here, and I'm going to add something to both sides. So now's the time when I get my new c. So I've got b, which is now b over a, which is a little confusing, over 2 squared. Well, how do I deal with a fraction and a fraction? Well, it's b divided by 2, which is b over a times 1 over 2 squared. So it ends up as b over 2a. That's kind of familiar, but now I'm going to square it. So it ends up as b squared over 4. That's kind of ugly. B squared over 4a squared. Right? B squared over 4a squared. And I'm going to do that on both sides. B squared over 4a squared. All right. Well, I know that on the right in the past, when we've had this happen, I have to get a common denominator. So in order to be able to have the same denominator, I need them to both have 4a squareds. So I'm going to times this one by 4a. That's going to get me that 4a squared on the bottom. So I'm going to go ahead and rewrite the right side as negative 4ac plus b squared over 4a squared. And on the left, I'm ready to factor this perfect square trinomial. It's an ugly perfect square trinomial, but it is a perfect square trinomial because we followed all the rules. This side is easy. There's no minuses around, so I know it's plus. What is it? Well, we said it's always that thing that happened before it was squared, so it's going to be b over 2a. Remember how that's what gets added each time to that. That's how we factor it, right? That went here. All right, so we're ready to take the square root of both sides. Some of you are starting to see where this is going, and some of you have probably seen this before. I'm going to take the square root of both sides, plus or minus. I've got x plus b over 2a equals plus or minus. Now remember, when we do this, on the bottom, if I see I have a perfect square, I'm going to go ahead and take the square root, so it's a 2a. And on the top, I just tend to like the b squared first. And then b squared, and then that 4ac is negative. This is starting to look familiar. I'm going to subtract b over 2a from both sides. They're not like terms. So I've got negative b over 2a plus or minus square root of b squared minus 4ac. That's also over 2a. So if they have the same denominator, I can write them all over the same denominator. Right, that was x equals. So I have negative b plus or minus square root b squared minus 4ac all over 2a. There you go. That hopefully rings a bell.